Hey, everybody, welcome to GopherCon Lightning Talks 2021, Day 1. Oh, it is so great to be back again this year. I just wish we could all be doing it together. Um, Hopefully next year, I miss you all in person, but that doesn't mean we still cannot have a wonderful time this year. So far, I think you'll all agree, the programming's been amazing. And, little secret between you and me, it's only going to get better. Why is it going to get better? Because we're going to have lightning talks 3 days this year. That's right. Not one day, not 2 days, 3 days of lightning talks. It's an amazing lineup of talks. Seriously, I'm so excited to see it. Every year I have the honor and privilege of being able to introduce uh, these new voices and new ideas into our community. And I really take that to heart every year, and I treat it as the honor and privilege it really is. So thank you all for joining me. I think you'll agree that these are truly some spectacular talks this year. So before I bring on our first contestant on the game, as I like to joke, let's go over the rules of the game. The rules of the game are quite simple. Each speaker will have 7 minutes to present their idea to you, the viewer. Whether that be an idea about a package they wrote and a concept they had, or just how to perfectly grind and roast those coffee beans. Um, they have 7 minutes. If, however, they start getting a little long in the tooth, at the 1 minute left mark, they will hear this. There we go. Gotta be faster with that, Jose. And of course, if they run out of time, the infamous curtains will close on them. That's the only time the curtain ever closes on Mark Bates, is when I'm demonstrating how the curtain closes. Anyway, with that said, I don't want to keep going on too long. We have such a great amount of content here to present to you today. So we're going to bring up our very first speaker here today. Alan, I believe you are with us here, correct, Alan?
Hi, yes.
Great. How you doing?
I'm doing great. Thanks for having
Great.
me.
Great. Well, it's great to have you. Where are you joining us from?
I'm here in San Francisco, California.
Very, very nice. You have a lovely painting and then a lovely piece of acoustic tiling over there.
Thanks. Yeah, that's my wife, and I made that thing in the middle
Lovely.
during my COVID pandemic project.
Fair enough. I love it. Well, awesome. Alan, I'm going to let you talk. You're going to talk a little bit about a new Redis implementation, if I believe. So take it away, Alan.
Okay. Hi, everyone. I'm Alan, founder of wakatime. wakatime provides dashboards and automated metrics for programmers using open source IDE plugins. I'm going to talk about how you don't need Redis. With Redis, you can only store as much data as you can fit in RAM. Today, I'll show how we can use disk space instead to cache much larger data sets. Feel free to reach out and contact me by email or find me on Twitter. So here's the wakatime dashboard, or leaderboard, sorry. Loading this leaderboard used to take over 30 seconds because we had to query the code stats for over 10,000 developers. That's unusable, actually, 30 seconds. So we definitely had to figure out how to fix this. So let's solve this problem together. We start by caching the page in Redis, the awesome in-memory data structure storage server. wakatime uses DigitalOcean, so I'll boot up a $100 per month server and set up Redis on it. This gives us about 16 gigabytes of RAM to cache the leaderboards. And we write a function get leaderboard from Redis cache. We pre-cache the leaderboard page in Redis. It's a simple get by key for the leaderboard. We can't just cache the main leaderboard, however, because we have permutations of leaderboard by language, by hireable badge, by country flag, and we have up to 100 pages of each of these permutations. Each permutation is about 140 kilobytes. So times 622 languages, times 250 countries, times 100 pages, that's a total of 2 terabytes of data that we have to cache. Thankfully, we can compress that down though to about 24 kilobytes per page. But still, that's about 363 gigabytes of data that we have to cache. 300 gigabytes is much more than that 16 gigabytes of RAM we have. So on our DigitalOcean droplet here, the RAM that we have available won't be enough to cache all of those leaderboards. So what do? We could upgrade to a $2,000 per month instance that gives us 256 gigs of RAM, but our 373 gigabyte data set still won't fit in that 256 gigabytes of RAM. So the solution is something called SSDB. SSDB is a drop-in replacement for Redis that uses disk space instead of RAM to store your dataset. SSDB uses LevelDB from Google, but it can also use Facebook's fork of a LevelDB called RocksDB. And LevelDB and RocksDB use SSTable key value library or key value table that is written by Google based on Bigtable. And using an SSTable, you can, as SSDB is able to look up keys on disk with a single seek. So it makes its performance on par with Redis actually. So now we can use this storage optimized instance from DigitalOcean for $155 per month instead of $2,000. And it comes with 450 gigabytes of SSD NVMe storage, plenty of room for our 300 gigabyte data set. And we just saved about $1,800 per month by not using Redis. And because SSDB works with your existing Redis clients, you don't need to update any code. You just change the IP address of your server and point it to the SSDB instead of Redis, and nothing else needs to change. There are some limitations, however, with SSDB. There are some differences between SSDB and Redis. So SSDB can only expire simple keys. Actually, let me start with there's no Lewis function support. There are some command changes, like some commands are renamed zadd and zset and some others as well. And probably the most cumbersome thing is that SSDB can only expire simple key value strings, not HMAP or lists, but you can always manually delete them with one command, same as Redis. So bearing in mind those limitations, SSDB is very simple to configure. It has less config options than Redis, and therefore it's extremely simple to set up. Just make sure to increase your Linux machine's file max setting so the SSDB can open enough sockets and file handles to be performant. And also remember to run the SSDB CLI compact command to reclaim disk space from deleted or expired keys. And I've included a handy one-liner for that compact command here that makes it easy to run from a cron script because normally it blocks on user input. But this gets around that, so you can run it automated. These are the two things you have to remember with SSDB. And if you're wondering if using SSDB instead of RAM or SSDs instead of RAM, SSDB actually performs better on average than Redis when writing keys and about the same when reading. And that's it for me. And thank you for having me. And mic drop.
Well, thank you very much, Alan. That's the virtual mic drop for you. Love it. Awesome. Well, thank you so much. I'm definitely going to be checking that out. Okay, so let's bring up our very next speaker, Marcus.
Yes, hello.
Hey, how are you? You can hear me then, I take it?
Yes, I can definitely.
Fantastic. How are you doing?
I'm good, thank you. How are you?
I can't complain. It's GopherCon.
I know,
Nothing
right?
to complain about. So where are you
I'm happy
joining
it's
us
happening.
from?
I am calling in from Aarhus in Denmark.
Denmark. Awesome.
Yes,
Interesting.
exactly.
And you're going to be talking about HTML components?
Yes, exactly.
That's
HTML
far out of my
components in
pay
Go.
grade, so I'm going to let you talk about that. Go for it.
I know, right? Right. So yeah, this is my lightning talk about HTML components in Go, or why I sometimes miss React. Because the thing is, I really like React. I've been a full stack developer for a long time. I've been working, with JavaScript, doing web UIs, and what we all know and love. There are two main reasons why I really like React, and none of them are actually technological. So the first thing is the mental model. It's just nice that it's so simple. It's quite elegant. It's easy to be productive in it, but also it's really easy to communicate to team members about how you put these components together in the front end, how you compose them together to build a greater whole, whether you're building a web UI or an application or whatever. So the second reason is the ecosystem. So no matter what component you really need, you can fire up your favorite search engine and then try to look up whatever component you need and find something pretty quickly, and then basically get it running with a fairly high percentage of probability. So that's why I really like React. But now I'm a Go developer, right? So how do I do this in Goland instead? So I've been writing Go since 2016 now. And I was really missing that way of writing components. So I thought to myself, well, I'm a developer. I could do something about this. So of course I did. So I'm introducing components. Of course, this is a wordplay between components and Go. And if you look closely, there's a tiny bit of DOM in there. So pretty good. Oh, and then wait. So let's go back to my reasons for why I like React and how does this apply to components? Well, one thing is it's the same mental model. So it's all components that are composable. It's the same idea, basically. You can build these components together until you have a web UI that you're satisfied with. So, and the basic premise is that you have some data that you put in and you want some HTML out, right? So that's how we build our UIs. So in components, the components, they are just Go functions. And I'll get to that in a minute. But before that, a little disclaimer. When I'm talking about this is all the classic web, or whatever you want to call it. So server-side rendered components that are from the classic request-response cycle. So there's nothing fancy about WebAssembly or anything going on in the browser. This is all just, we want to generate some HTML, do one thing and do it well. So with that said, let's have a look at some code. So we have our imports, of course. We import the package components. And then also you'll notice I'm using a .import for the HTML package inside components. So I know this is generally frowned upon, but bear with me for a second. So here we have our actual function, the component, which is a navbar in this case. So as you see, it's a Go function that we know and love, and it returns something called a node. And I'll get back to what that is exactly. But it returns this nav thing with a class, an ordered list, some list items, some links that have an href attribute and some text in them. So basically, if you can read HTML, you can pretty much read this as well. But this is only one component with some HTML components underneath. So how does this look when we refactor it? So let's take our navbar and extract the navbar item, so basically the list item. And then add some properties, the data in and the HTML out I was speaking about earlier. So there's nothing really surprising about any of this. If you've ever written React, this is basically how you would do it as well. So now you have a navbar and a navbar item, two components. Let's have a look at a slightly more complex example. So we have some authentication going on, maybe. We have a logged in parameter that we pass to a navbar component, as well as a current path on where we are in our web app. So we can use the if function that's also provided by components, which is a really simple function that just takes an expression. And then if that expression is true, you basically return the component. And if not, you don't. So you get these nice inline declarative ways of describing components. Also, another helper is the classes helper, which is basically a map from CSS classes to, again, a Boolean expression. And if that's true, the class gets included. If not, it doesn't. So pretty simple like that. So how does this render to whoever is viewing it? Well, also, again, our basic HTTP handlers that we all know and love from the Go ecosystem. So in this case, we have a response writer, W. We have a home page component, and we call render on it, and then pass it that writer. And that's basically it. Of course, in this case, it returns an error, but as you remember, you should always just ignore errors. So this node interface I was speaking about earlier, what does it do? Well, it's really simple, like most good interfaces in Go. So it has one function in it. It's called render. It takes a writer, and it returns an error, and that's basically it. So if you want to do a component, you have to implement this interface, and that's it. And of course, in components itself, as you saw, a lot of the HTML elements and attributes are already included for you, so you don't have to write them yourself. If there's anything there that's not included, then you can use some functions for that as well. To basically, so there are some other helpers as well. Map for mapping data to components, group for grouping elements, raw for injecting HTML, and textf for string interpolation, and some other stuff as well. So the ecosystem is components, and hero icons is something I created. So icons are by the excellent Steve Sugar of Table and CSS fame. But yeah, this is something I built, and of course I can't build all the components myself. So this is where you come in. I'd really like for components to take off, and then people start building these components. So if you want to join in on the fun, go to components.com, check it out, download it, have a go at it, try it out, publish whatever you find, and that's basically it. So yeah, thank you very much. This was a talk by me. You can find me on Twitter, MarcusRGW. And I also build online Go courses at golang.dk. Thank you very much.
Thank you, Marcus. That was awesome. I told you it was going to be above my pay grade. HTML, it ain't what it was when I started doing it in 99, kids. That's actually 96. Sorry. Anywho, I was getting ahead of myself there. Making myself a little younger than I actually am. All right, so enough about me. Let's bring up our next presenter, Tom. Tom, you there?
Hi there, Mark. How are you doing?
Hey. All right, and yourself?
Very good here. Yeah,
Fantastic. Where are you joining us from?
I'm joining from Zurich in Switzerland. And we've got
Switzerland, yes, you can tell by the accent.
I'm British, actually, but I've been here for a few years.
Nice, nice. Awesome. And you're going to be talking about chez moi, is that correct?
Yeah, you got the pronunciation right. You're French. Perfect.
I have no idea what that is, but why don't you let us know? Thank you very much. Go for it, Tom.
Cool. Thank you very much, Mark. So, hi, I'm Tom Payne. I'm a developer at Isovalent, but this is a personal project called Chez Moi. This is French for at my house. It's a dot file manager, and it's only been made possible by Go. And basically, if Go didn't exist, Chez Moi wouldn't have been successful. So this is interesting if you're writing CLI applications for users and you want to get them into as many users' hands as possible. Firstly, what is Chez Moi? It's a cross-platform dot file manager, your dot files, your config files for Git, Bash, ZSH, Vim, whatever. It generates them for a single source of truth across a massive range of platforms with multiple install methods. It's super secure. You can store your secrets in your password manager so they never appear in your dot files repo. You can encrypt whole files using GPG and Aggie, and it's become really popular. And this popularity is really thanks to the decisions that the Go team have made. It's got 5.4K stars on GitHub, 87 contributors. The link there is you to check it out, github.com/Chez Why should you use it? And it enables you to maintain a familiar, customized environment. All the effort you've put into configuring your tools, you can now have that across multiple diverse machines, whether it's your home laptop, your work development machine, a Windows box. And what we're seeing at the moment is that although we'll hang on to our laptops for a long time, we're increasingly developing in ephemeral environments like GitHub code spaces or dev containers. And it's really nice to be able to bring in all that work you've done setting up your system into a new system very quickly with a single command, or from a single version controlled branch, so you get backups and history and all sorts. This is a graph of Chez Moi's popularity. It's the yellow line here. You can, compared to the other top 4 dot file managers at the moment. And you can see that in 3 years, it's gone from nothing to being the #1 doc file manager. And I think this is only possible because of Go. How is Go brought real advantages to users? The first thing is it makes it really easy for users to install. This decision from the Go authors to have a single static binary is massive. There's no language runtime you have to install. Imagine having to install Python or Ruby from scratch on the machine, particularly if you don't have root. There's no dependencies. Actually, everything gets built into the binary. So it's just a single file that you can copy on within curl, SCP, whatever. Go embed allows us to include lots of other files, and Chamois uses it for documentation. So even though I'm distributing a single binary, there's a Chamois docs command that gives you all the documentation embedded in. The cross-platform by design, the Go authors really supporting Windows as a first-class citizen is a fantastic win because most doc file managers don't run on Windows. Windows is very different from the classic Unix systems, but thanks to Go's efforts to include Windows, we get first-class doc file manager on Windows too. And Go's text template library is fast becoming the standard for configuring many systems now, particularly on templating YAML. But also, it's not just for users. It makes it really possible for developers. It makes it an easy project to contribute to. The high-quality platform standard library means it's just less work that you have to do as a developer to get cross-platform compatibility. An interesting thing as well, compared to other languages like Rust or Python, the concurrency built into the language means that all Go libraries are compatible. They all use the same concurrency primitives. In contrast with Python, where you have to choose between gevent, twisted, or in Rust, which version of async, whatever you're using, they fragment the ecosystem. But Go doesn't suffer from that. Of course, you've got excellent cross-compilation. There's some fantastic tools from the community. I want to particularly highlight TestScript, which is actually pulled out of the Go internals project, which is this fantastic integration testing, a project called Go Releaser, which if you're distributing your Go binaries, it builds you packages for everything. It's absolutely brilliant. Go check it out. But another thing I've sort of observed when learning the Chamois is that it's not just shared libraries that matter, it's also the tools that you might have to depend on. So for example, Chamois allows you to encrypt whole files with Aggie, which is a new GPG-like encryption tool. But rather than relying on an age binary, as this is distributed as a Go library, I can embed this directly into Chamois. Similarly for Git, thanks to the great Go Git project, you don't even need to install you don't need to install Git on your machine to be able to check out your Git repo. And I'd like to encourage people as a pattern to use that. If you're building a command line tool, please do make a library version of it so that others can embed here and avoid those dependent on external binaries. That's it, very quick. The lessons I want you to take home. If you want to build a popular tool to get maximum user reach, you want to minimize your external dependencies, you can make your tool available as a library. And of course, please do go check out Chamois. Thank you very much indeed.
Well, thank you very much, Tom. I appreciate it. It was wonderful. Just to double down on something Tom said, I agree. Make your CLIs available as importable libraries. I was just telling some of my students last week that exact same advice. Make it so that us tool developers don't have to have dependencies in external binaries. That was an excellent talk. So up next we have Yuri. Yuri, are you with us?
Hi, Marek.
Hey, how you doing?
I'm okay, and you?
I'm doing great. It's GopherCon.
Yeah, awesome.
Where are you
always.
joining? Exactly, where are you joining us from?
Yeah, I'm joined from Kraków. It's in Poland.
Ah, very nice. Yes, exciting. And you're going to be talking about doing front end work. Is that right?
Yep, right.
Oh, all you people in the front end work. Okay, you're
Yeah.
far better at than I am. Go for it.
Okay, thanks. So, hi everyone. Today I'd like to present the library named Kyoto. It's an SSR first Go front-end library, and if it's not so interesting for you, feel free to take a cup of coffee during these 7 minutes. So, but first, let me introduce myself. I'm Yuri Zinitz. I'm software developer at Akamai, but also a core developer of Broker One real estate platform on part-time. And the overall story I'm going to tell is actually related to Broker One development process. So Mm, before I start to talk about Kyoto itself, it's really important to know backstory because we are not creating technologies for technologies, but for solving different problems. So, long story short, in the beginning of the platform creation, we decided to create a prototype first. We took a well-known JavaScript framework with a set of ready-to-use material components. And as usually happens, the prototype became the main project. Over the time, we began to feel the impact of this decision. It was hard to keep overall project setup clean and tidy. We had a lot of difficulties with SSR, memory leaks on server side, and performance core issues. We completely lost control. And after this discussion, our team decided to drop this prototype and go in more traditional way, use template engine. And so, why did we choose such a radical way? We had several reasons. Unnecessary complexity was one of those reasons. Not many people really understand how their project setup works under the hood. We pack with tons of configurations, Babel, tree shaking, lazy loading, and especially when it's not work as expected. You need to bring a significant runtime and virtual DOM just to render a simple things like articles or pages with minimal dynamic behavior. Template engine reduces overall complexity and allows taking full control over front end. Also, this approach reduces amount of bugs and quirks because we can find most of the problems on building and testing stages. And so our project became much better with this migration, but we faced some common inconveniences. We have started to use more copy paste. Our handlers became a spaghetti because of asynchronous API and database requests. And we all have to admit vanilla JavaScript is quite verbose for simple dynamic things. That's why Kyoto was born. And we are going further. What Future Kyoto provides? How it solves these issues? First issue solved is called organization structure. For each page and component, you have separate Go structure and template definition. You can include data fetching and display logic just right inside the component. Second thing I provided is page rendering lifecycle. This allowed me to solve asynchronous calls issue. You can implement asynchronous method for components, and it will be called with own Go routine under the hood on page rendering. As an example, you have 10 instances of the component on the page. In that situation, 10 Go routines will be created for each asynchronous call. And the most interesting thing in this library I've implemented is a built-in dynamic functionality inspired by Hotwire and Laravel Livewire. It's pretty simple and limited because it's created for simple things, but people really liked it, and I'm extending functions over the time. And as the project has solidified its core idea, I'm able to make some plans for the future. We are already working on UI kit based on Tailwind UI and already using it for our internal tools. Anyway, it still needs a lot of work. Also, one of the features I'd like to provide is a server-side state. This approach will reduce initial amount of data to transfer between server and client. And last but the most interesting thing and crazy idea I'm experimenting on is bringing the whole rendering process to the edge workers. It's giving to us a serverless setup, insanely fast responses. Unfortunately, Cloudflare edge workers have a lot of restrictions, like 1 MB executable size limit, and don't have official support for Go. And I was able to run Go and on the edge workers with TinyGo compiler and Wasm, but it's not enough to be able to use Kyoto as expected. And so here is a quick summary for this talk. I think Go has a big potential and it's not limited by current domain. Otherwise, it would be impossible to create tools and libraries like this. And I'd like to note that Kyoto is not framework by its own. On my opinion, combination of UI kit, project blueprints, and best practices are actually became a framework. And I'm not creating Kyoto opposite to JavaScript solutions. Even more, it's possible to integrate them. I just believe that every solution has its own purpose, and I hope the solution will have someone too. So you can find all the needed links on this slide. Don't hesitate to contact me directly anytime. And that's all from my side for today. Thank you for your attention.
Well, thank you very much, Yuri. That was
Yeah.
wonderful. Ah, awesome. So much great content. Well, we've got to just keep going here. So I'm going to bring up our next speaker, Ron Evans. Ron, join us on stage.
Hello, GopherCon. Yes. All right. It's so great to be back with you, Mark. But Mark, what happened to your beard? You were supposed to have a beard. I trained the targeting computer for my drone to look for you with a beard. So
well, that was the plan. I figured I would grow the beard, fake you out, then shave it off.
clever.
You like that? Well,
Mm.
hola, mi hermano. It is lovely to see you.
It is great to see you as well, my friend.
Again,
And-
wish we could be doing this in person.
Well, we miss you all. You can see I'm wearing my retro GopherCon t-shirt, and I'm wearing my GopherCon hack session pit crew t-shirt
Love it.
shirt. So yeah, we're ready.
Okay, well, give us the update on TinyGo.
All right. So this is a small update about TinyGo. So I am Dead Program, aka Ron Evans in the real world, but that's not really that important. Technologists for hire, that part is always very important. At the hybrid group, where we're a bunch of technologists for hire doing software for hardware companies. So I'm here with GopherBot. So GopherBot joined the universe 2 years ago at GopherCon. And so you can go get the source code and the 3D models to build your own GopherBot. I've also got my Go badge. So we never actually got to introduce this, unfortunately, because the COVID happened right then. But this is a Go-powered badge. So yeah, next time we're all together in person, then we can hack on those together. So those were both made using TinyGo. So if you've been living in a very remote place, you don't know about TinyGo, but it's a Go compiler for small places like microcontrollers and WebAssembly. Yes, you don't need to use Rust for WebAssembly. You can use Go. So let's take the current stats. Over 9,000 stars on GitHub, 495 forks, with the latest dev branch having over 2,400 commits, over 100 contributors. Thank you all so very much for making TinyGo what it is. Over 74 different hardware boards supported and 74 different sensors and displays. And since our last release about 3 weeks ago, 2.75 commits per day since the last release. So the project's going fast. So let's talk about a couple of quick highlights from that last release. Lots of runtime and standard library support improvements. So, your garden variety Go code will maybe just work now. Lots of work done on WebAssembly, especially the WebAssembly systems interface, and we'll see some examples of that. And then Windows. Yes, you can actually build a Windows executable with TinyGo now. It's absolutely amazing. So let's take a look at some TinyGo out in the real world. So here is a really cool tweet from Matt N, known for the MJPEG package as well as the TF Lite package. So Matt N in Japan is very excited about being able to build Windows executables. And we can see here that the normal Go compiler, about 2 megabytes in size, with TinyGo only just under 300K. So also from Japan, Takasago-san, who is a longtime contributor and done lots of cool work in TinyGo, had a really awesome TinyGo workshop recently featuring the Wio terminal from Seed Studio. So that's a very cool workshop. Content's online. Speaking of WebAssembly, so you can actually use TinyGo with the Envoy proxy, and there is an SDK which is available from Tetrate Labs. It's the proxy WASM Go SDK, and it works with TinyGo and only TinyGo. Since you can't write WASM WASI applications using the regular Go just with TinyGo. So check that out. So speaking of more WebAssembly excitement, so recently the WASM 3 runtime project released the embedded WASM apps, which you can actually compile WebAssembly code and run it on embedded microcontrollers. So it's a different way of achieving the same sort of thing you could do just with regular TinyGo, but it supports assembly script, Rust, C++, TinyGo, and Zig. So another awesome place for WebAssembly and TinyGo. So the IOTA project, if you're interested in blockchain stuff, recently released support for using TinyGo as the programming language for their smart contracts. So that's pretty interesting, if that's a new space for many people. And then the Astro project recently, jumping ahead of myself here. The Astro project has got a front-end development package compiler that you can compile the WebAssembly using TinyGo. And in fact, their online astro.build/play website uses the TinyGo compiler. Then, speaking of interesting and cool content, there was a great series that was put together by this blogger, and they wrote a whole series of learning Go. This particular article talked about how to create a Game Boy Advanced game in Go using, of course, TinyGo. So then back to the businessy sort of stuff. The legendary Ray Ozzy's company, Blues Wireless, is using TinyGo for a bunch of very interesting things. Go check them out at blues.io. Then we've got, there's so many things. So Tobias Thiel gave a talk recently at Embedded Fest, which is Eastern Europeans' biggest Linux and embedded conference. So that was a really cool talk. You can check that out on YouTube. Also, Tobias published a book about TinyGo earlier this year. Yes, there is a paper and electronic book for TinyGo. Check that out. So earlier today in Australia, there was the Australia IoT Christmas edition. So yeah, time for the Christmas edition lights from GopherBot. And what is his name? Leon Champton gave a talk, and actually Leon is going to give a lightning talk, I think, tomorrow or the next day about TinyGo. And we've got the suborbital dev recently on the Atmo application server, which is back-end Go, using TinyGo and WebAssembly. So there's going to be a talk by Connor Hicks after this, a full-length talk. So check it out. More info at tinygo.org. You can follow us on Twitter at tinygolang. And thank you so very much. It's been great to be here with you.
Thank you so much, Ron. Awesome. Can't wait to see you in person some point. Awesome. Well, thank you all so much. Thank you, Ron. That was excellent. And you know what? I survived. Not a mark on me, Ron. Try again next year. Anyway, okay, we have one final talk for you today. They've all been so amazing, and I can only imagine this one's going to be amazing too. Let's bring up our final speaker here. Ryan, are you with us?
Yep. Hello.
Hey, how are you?
I'm doing great.
Great. Where are you joining us from?
Denver.
Denver, Colorado. Fantastic. Home of the original GopherCon. Did you ever attend any of the ones there?
Unfortunately, no.
Oh, real shame. Yeah, the first 5 were there. They were really, that was, honestly, I loved having it in Denver. It's one of my favorite places. So awesome. You're going to talk to us a little bit about memory usage today. Is that correct?
Yeah, I just have a little story about memory optimization.
Fantastic. Go for it.
So, hi, I'm Ryan Hitchman. I'm a software engineer from Sourcecraft. And today I'm going to be talking about some work that we did this year. So Sourcecraft is a universal code search engine so that every developer and company can innovate faster and find their code. And most of our code is open source, including Zookt, which we use to provide regex code search for 2 million repositories. And this year, a large part of our work was scaling our Sourcecraft.com search engine from indexing 300,000 to 2 million repos. And a large part of that effort was reducing the RAM usage for Zookt, for the Zookt servers responsible for handling most of the code search backend. So Zookt is a Go program initially created by Hanwen Nians at Google that performs trigram-based regex search. And that means that it builds an inverted index that has a map of every 3-letter sequence of characters or trigram to its location in a repository. And then by iterating over the locations of each trigram, you can pretty efficiently implement most regex searches. So initially, these are some graphs of our monitoring. The large purple area on the left is the RAM used by the different Zookt replicas. So it's taking about 500 gigabytes of RAM, and the tiny lines under it are all of the other jobs. So by far the majority of our spend for cloud servers was on Zookt. And then the drops are implementing these changes that I'm going to describe. And it brought it down to about 150 gigabytes of RAM instead, which let us scale up a lot more. So Go has some really good profiling tools with deep runtime integrations, and it makes it really easy to collect memory profiles to show you exactly what's occupying the heap. There's lots of blog posts and good documentation about them if you look for it. So as a first step for optimization, I built a test corpus from all the files that one of the backend servers was indexing. And then I collected a memory profile for that. So this shows precisely where it was using memory and gave me the first indications of what needs to be looked at. So the corpus represents 19,000 different repositories from GitHub mostly, 2.6 billion lines of code, and about 166 gigabytes of disk space. So this memory profile has 22 gigs of live objects on one server. The total RAM usage your Go program uses does depend on other garbage collection things going on, but it's pretty decent, and we do set a slightly more aggressive garbage collection threshold. So in this case, we set a threshold of only using 50% more space than live objects instead of twice as much, which is a default. So digging into the code, 2/3 of the RAM usage is by this one function, which is building effectively a map from 64-bit to 64-bit ints to 64-bit structs here. And Go maps are very fast, but they have quite a bit of overhead per entry, 40 bytes. And when the actual data we're storing here is only 8 bytes, that's or only 16 bytes, sorry, that's quite a large overhead. So it's worthwhile to implement a more compact data structure for it. There's many different kinds of dynamic maps you can implement, but all we really care about is being dense and static. So sorted arrays and binary search works really well. So as a first pass, just switching from a Go map to 2 slices, got from 15 gigabytes to 5 gigabytes. And this has logarithmic lookup speed instead of O of 1, but it did not present any problems for our particular use case. And there's a few more things we could do for our usages where instead of an array of 64-bit ints, we can do 2 arrays of 32. But and there was another switch for and that reduced it down to 3.5 gigabytes. And yet a more complex one shifts ASCII trigrams because we're indexing Unicode, and ASCII is much smaller. So that got down to 2.3 gigabytes. So we've slashed this one data structure from 15 gigs to 2.3 with no real problems. And a lot of these could be generified now, but at the time generics were not available. So as we shrink the largest problem, other pieces start to dominate. So a lot of pieces of metadata that were loaded from disk into memory, we changed to be memory mapped and accessed on demand. And some other things were left compressed until needed, which shaved off another 2 gigs. And I think the easiest takeaway here is if you have big static slices, you are probably wasting memory because the excess capacity you have that you're not adding to is just using memory. So if you simply copy them into a precisely sized slice, you can save a lot of memory. This was worth 500 megabytes of improvement here. So putting it all together, the memory profile looks like this, which is a 5 times reduction overall, which means that with the exact same resources, we can serve search queries for that many more repositories without requiring more servers. And it went from about 1,400 kilobytes of RAM per repository loaded to 310 kilobytes with no measurable latency changes, which is the really important thing. And I guess in summary, memory is really expensive. We've had a few other talks already about how RAM is expensive and getting giant RAM servers is costly. So have you profiled your applications? You can find some really big wins with small changes if you look with the profile. Greenfield memory optimization is very satisfying, and it's a good distraction from all the other feature work you're doing. So go out and optimize some code.
Well, thank you very much, Ryan. That was wonderful. I'm definitely going to make some of those changes. Well, with that said, everybody, we've come to the end of our program. Thank you very much for joining us. We'll be back again tomorrow, Thursday, and also Friday at the same time with more incredible talks. So with that said, I'm going to throw it back to the studio so we can hear more great content. Thanks for joining us.